Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Marko Navijalic.
Thank you, William, and hello to everybody. Thank you for joining me in our today's presentation, where we will try to find out the answer to the question, can the right solvent improve your yield? Today, we will start by comparing solvents to your standard water-based chemistries and see how that translates into your cleaning process. Then I will focus on your electronics production and see where we can use solvents and how can they help you improve your yields. There's an old saying when it comes to parts cleaning, like dissolves like. What does that mean? In chemistry, molecules are described as being polar or non-polar. This means that polar molecules will likely dissolve other polar molecules, while non-polar molecules will be more efficient on other non-polar molecules. So let's cover the basics. Aqueous cleaners, they are water-based cleaning solutions where certain compounds like surfactants, emulsifiers, or pH buffers are mixed with mostly water. On the other hand, solvents work by dissolving the soil in the cleaning solution. That means that in most cases, they will not require any additional additives. This also means that this process relies less on the mechanical action of the machine when compared to the aqueous process. The aqueous process will have to utilize agitation, pressurized spray, or ultrasonics. Aqueous products are also much slower at evaporating. This means that your solvent process, in most cases, will eliminate the need for a thorough rinse and drying process after the cleaning, which are always a big part of the water-based cleaning process. And a very important property of the solvents is that they have a much lower surface tension. What this means is that this enables them to much more easily penetrate into small crevices and gaps, making them very useful in cleaning very complex products with small pitches and very low stand-off heights. So let's see how that translates into our cleaning process. Here you can see all the four main factors which influence your cleaning process, the four forces of cleaning, if you will. With the aqueous process, you will have to carefully monitor all of these factors. First, you will have to maintain a proper concentration because you have to maintain your cleaning efficiency while at the same time not causing any compatibility or foaming problems. Because solvents are much more effective and rely mostly on chemically dissolving your soils, all the other factors like time, temperature, and mechanical energy will be of much less significance than in a water-based process. This will in turn result in a much faster and simpler process, and because saving time and money is your goal, that is what you want. So let's look where do solvents fit in electronics production. Here we have a typical SMT production line with your usual suspects, the printer, solder paste inspection, a pick and place machine, and a reflowing oven. So let's start at the very beginning of the process, the stencil printer. And let's see how we can apply solvents to improve this process. So stencil printing is a critical step in the electronic assembly process, and it has been reported that around 64% or sometimes even up to 80% of the defects in the electronic assembly process are caused by the stencil printing process. That's the reason why under-stencil wiping has gained increased interest over the last several years. Here you can see typical steps for this process. I won't go further into much details. For this, I would highly suggest you check out our other Tech to Tech series, specifically on under-stencil cleaning. But in this presentation, I wanted to show you how choosing the right solvent for under-stencil cleaning can increase your yield and throughput. So let's compare two different solvents used for this application. Isopropyl alcohol, or IPA, is, or I should say, was the most common solvent choice when a wet wipe is used. Historically, the choice of IPA made sense because most solder flux formulations were based on it, so therefore it was a good match to dissolve most of them. However, nowadays, solder paste manufacturers are moving away from IPA-based fluxes for multiple reasons. In the photo below, you can clearly see that IPA is a poor match for most modern solder paste formulations, while on the right, you can see that a properly engineered solvent can fully dissolve the solder paste, which is what you want to see on your stencil. Furthermore, while both of these solvents evaporate quickly, IPA does evaporate a bit faster, which actually causes problems because it increases the amount of IPA you need to use for a single wipe. It is also important to note that IPA has a flash point of just 12 degrees C, and for our listeners across the pond, that is 54 F, which means it is flammable already at room temperature, while an engineered solvent will have a flash point much higher, usually above 60 C or 140 F, making it a much safer alternative. So let's now do a real-world scenario comparison of both of these solvents in production and assume you have 5 SMT lines, which means 5 printers. You work 2 shifts per day and have a typical print cycle time of 60 seconds and a wipe cycle time of 30 seconds. What our testing has showed is that we typically use around 5 milliliters of IPA for each cycle compared to 2 milliliters for a properly engineered solvent. Also, because of the much superior cleaning of the engineered solvent, we were able to significantly decrease the wipe frequency, in this case double the amount of prints per wipe you can do, which will have a big effect on your production throughput. By doing this, by using the correct solvent, we were able to increase your yield from 85 to almost 95%. This will cause your number of defects to decrease significantly. And furthermore, we have also increased the number of prints per year by 17,000 per line. And what you can also see from this results is that the total amount of wipes per year has been reduced. This in turn will save you a lot of money on the consumption of both the solvent and paper. So it's easy to see here how a right solvent was able to increase your productivity, increase your yield, and also save you money and time. So what is our next cleaning task, you might ask? Well, of course, cleaning the flux residues which remain after the reflow soldering process. Typically, we use a water-based product for this application, but let's have a look at how solvents can be used as a safer and faster alternative for this application. This is a process called vapor degreasing. So let's just get into the basics of how vapor degreaser works. So here is a typical two-sump vapor degreaser, which you'll see most often on the market today. Typically, you will lower the parts into the boil sump where the cleaning is taking place. And then for the rinse step, you go into the cleaner and slightly cooler rinse section, where you can also have some ultrasonics or spray under immersion. And then you go back into the vapor zone to get your final pure rinse. Lastly, you will raise the boards through the freeboard zone for your final drying step. If you want to know more about this process in particular, I would suggest you check out our Tech-to-Tech series on vapor degreasing. Generally, solvents used in this process will have no problems in cleaning mostly rosin and RMA fluxes. However, with all different no-clean flux formulations today, they can have trouble dissolving some of them. That's why we have developed a special DuoSolvent process in order to be able to clean most, if not all, of the modern fluxes while still maintaining a waterless process. This process includes a separate first step of cleaning in a different solvating agent. The biggest advantage here is that you can choose between a variety of solvents in the first step, depending on the flux you are cleaning. And in the future, if you change the solder paste or the flux you are cleaning, you don't need to worry because you can also change the solvent in the first step without affecting the process in any way. The rinse solvent in the vapor degreasing step will stay the same always. And this will give you a lot more freedom and future-proof your cleaning process. So how can solvent cleaning improve your productivity and increase yield in this application? First of all, by removing the need for any DI water rinsing and then drying that water, this process is much faster than a standard aqueous batch process. Typically, we're talking about a total cycle time of 10 to 15 minutes for vapor degreasing, which compared to the water-based cleaning of 45 to 60 minutes will increase your production time significantly. Bath life is also much longer with solvents. While water-based products can typically hold up about 2 to 5% of the soil, which we call NVR or non-volatile residue, solvents can last for much longer, sometimes even up to 20% of NVR. Additionally, solvents have an advantage that they can be distilled, which means that they can be reused again and again for a much longer time. This will give you higher yields, as your cleaning result will be affected much less by a contaminated bath. So where else can we use solvents in our SMT production? What about the process where you have the most heat, flux, dust, and other contaminations? I'm talking, of course, about your reflow oven and maintaining it. So, for example, take a look at this dirty oven. Can you imagine your boards passing through it and not getting contaminated? By using solvents to properly clean and maintain your oven, you will significantly improve your machine performance and life. This will reduce the potential for relocating the contamination from flux and other soils from dropping onto your assembly. Since this is, after all, a manual process without any heat, rinse, or dry, solvents proved also here to be much more efficient than water-based products. As a result, less downtime and improved performance will give you better yields. So to recap what we learned today, using solvents instead of aqueous cleaning will give you a simpler and faster process, which has better compatibility with your substrates, and also you will be able to penetrate and clean your highly complex parts. In stencil cleaning, a proper solvent will give you much higher yields and faster production times by reducing the number of wipes needed and reducing consumption. In PCB cleaning, that will also give you a faster cycle time and a more consistent cleaning result throughout the life of your bath, which will be much longer than that of a water-based process. And lastly, by using solvents and maintaining your soldering ovens, you will be able to increase their performance and significantly reduce downtime, which in turn will provide you with higher yields. So here are some frequently asked questions about this topic. Aren't solvents flammable and therefore dangerous to use in production? Some solvents are indeed flammable, and we strongly discourage from using these products for your cleaning applications. This includes IPA because it has a flash point of 12C, remember, which means it is very dangerous and not safe to use. However, most manufacturers design modern solvents today to be non-flammable and to have a much higher flash point, making them safe to use in your normal operating conditions. As a general rule, you should always look for solvents with flash points above 60C. Are there limitations to using solvents in cleaning electronics? As with everything in life, there are no one-size-fits-all solutions. So solder paste and flux formulations are changing and improving all the time. And this means solvents which clean those solder paste and fluxes might not work on another formulation tomorrow. The efficiency of a particular solvent will always have to be tested on that particular soil. Also, solvents contain VOCs, or volatile organic compounds, which evaporate in the atmosphere. Therefore, these products are not suitable to use in your standard spray and air cleaning equipment, especially if there is heating involved. You should always have good ventilation also wherever you are using solvents. And lastly, are solvents more expensive than aqueous products? That's a very good question. Typically, the answer is yes. Solvents are generally more expensive than your comparable water-based products, and also they are used at 100% concentration, whereas water-based products you would use at a much lower concentration. This will increase your initial cost for a bath fill. However, by being able to hold much more soil, thus having a longer bath life, and by eliminating the need of rinsing with water and drying afterwards, you can actually save a lot of money in your process in the long run. And with that said, I will finish for today. Thank you all for joining, and I will hand it over to William.
Thanks, Marko. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.